equations and inequalities. Okay, so I welcome you to this video, and we're going to be looking at equations and inequalities. So it's just going to be two in one topic, right? So now we'll start with equations. Okay, now of course, what is an equation? Now in mathematics, okay, an equation is simply a mathematical statement, right? So any mathematical statement okay that shows that two mathematical expression are equal. So it's just a statement of equality. Okay, statement of equality simply means that it is a mathematical statement that shows that two mathematical expressions are equal. For example, if I say that ax is equal to b, this is an equation. So what I simply means that what I have at the left hand side of the equation is equal to what I have at the right hand side of the equation. Okay, so I hope that is well understood. So now in this tutorial we're just going to consider two types of equations. Okay, we're just going to consider linear equation. We'll consider one briefly, then of course we consider another type of equation known as quadratic equation. A quadratic equation is a nonlinear equation. So I'm starting with the linear equation. So I'm very sure this is just very simple. This is just easy. Okay, just an introduction. Okay, um i'm I'm very sure that you must have actually worked on this before. Now for you to solve an equation, if you are being given a linear equation to solve, for example, okay, why is it first, why is an equation called linear equation? And that's exactly what I'm going to explain now. Now this is an example of a linear equation. I have 3x, excuse me, 3x, okay, minus 12. Minus 12 is equal to 0. This is a linear equation. Why is it called linear equation? Why? Because the variable, all right, the power of the variable, the highest power of the variable, or even the unknown. Remember, the variable in an equation is also the unknown, okay, is actually 1. So x here, the power of x is 1. So any equation in which the highest power of the variable is just 1, such equation is a linear equation. And okay, so invariably now, if you are being asked to solve this equation, you are also asked, it simply means that you are being asked to find the value of x that will satisfy this expression. What is the value of x that will satisfy this expression? That simply means that you're looking for the value of x in such a way that if I put that value of x into this expression and of course evaluate it, it should be equal, should be equal to 0. Okay, now let's see how we do that. I know very well that you know how to do this already. Simple. Okay, for you to solve this, you just take the minus 12 to the other side of the equation, right? That makes it plus 12. Then for you to get x, now you divide both sides by 3, so which actually use x to be equal to 12 all over 3. Okay, and that is 4. So now x being equal to 4 is what satisfies this expression. How do I know? Okay, it simply means that if I should substitute x equal to 4 in this expression, I should have 0. Let's try that. So it's going to be 3 times 4. Okay, then minus 12. Of course, 3 times 4 is 12. 12 minus 12 is 0. So that is that. Okay, so this is a simple linear equation. Okay, I'm not going to emphasize on linear equation. My whole emphasis is going to be on quadratic equation. So now let's now get to a quadratic equation. All right, Now, what is quadratic equation and how does it look like? Any equation of the form ax squared plus bx then plus c being equal to 0, that is a quadratic equation. Okay, where a, b, c, they are all real numbers. Okay, a is the coefficient of x squared, b is the coefficient of x, and c is the constant value. So now, why is this equation called a quadratic equation? Okay, now one peculiar thing about a quadratic equation is that the highest power of the variable, the unknown, okay, is always 2. So that's why you're having ax raised to the power of 2. So that is why it is called quadratic equation. Now let's now go to the solution of quadratic equation. Now I'm very sure that you must have actually treated the solution, okay, different method of solving quadratic equation. Very basically from this topic, okay, it's even treated in college or secondary schools, right? Okay, so now I'm sure you know different method, but I'm only going to pick one method, which of course is general method, which is the general formula. That general formula of solving quadratic equation is actually gotten by completing the square, and I don't want to go through that process of completing the square because we have a lot to do in this tutorial. So let's go to that general formula. So, and of course, if you are asked to find the solution of a quadratic equation, invariably the solutions to the quadratic equation, which is not just one, okay, is known as the roots of the equation. So the solutions is also called the roots of the equation. So now, what is the general formula for this solving this? So the general formula of finding the value of s is given as s is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. With this general formula, okay, you'll be able to solve any form of quadratic equation, okay, whether the equation can be factorized or it can't be factorized. So this is what's called general formula, and some people refer to it as almighty formula. Okay, so now let's use this formula for just one equation. Let's look at a simple equation where we have let's look at s squared minus 5x plus 6 equal to 0. So when I use this formula to solve this, first of all, we have to find what our a, b, and c, okay, our constant. So in this case now, what's my a? My a is always the coefficient of s squared, which is 1. The coefficient of s squared is 1. And what's my b? My b is the coefficient of x, which of course is minus 5 here, okay. And excuse me, okay, what's my c? My c is plus 6. Okay, so now let's solve that. So that's going to be my x now is going to be equal to minus b. That's going to be minus into minus 5, close bracket, then plus or minus, okay, the square root of b square, right, which is still minus 5 square, okay, minus 4 times a. What's my a? My a is 1. Then of course times c. What is my c? Okay, my c is 6. All right, so I have 6, then divided by 2 times 1. Okay, so let's do this. Let's minus into minus 5 is going to give me plus 5, plus or minus. Now I will tell you the reason why we have plus or minus. Remember, quadratic equation have roots, okay, So invariably, in fact, quadratic equation have two solutions. Okay, the root of the quadratic equation is 2. So why we have plus or minus is that for I use plus for one solution, then minus for the other solution. Okay, so please take note of that. All right, so now the square root of minus 5 squared is 25. You should know that already, because minus times minus is plus. So minus 5 times minus 5, that's going to be plus 25. Then of course here 4 times 1 times 6, that's going to be 24. Then divided by 2. Okay, so let's just get this over with. Okay, so invariably now my x now is going to be equal to 25 minus 24, that's 1, and the square root of 1 is still 1. Okay, so I'm just having 5 plus or minus 1 divided by 2. Okay, so now how can I now get my x? So x is either 5 plus 1 divided by 2. Remember, we use 1 for one solution, or okay, I'll use plus, pardon me, I'll use plus for one solution, then I'll use minus for the other solution, or x is equal to, then this time around 5 minus 1, okay, then divided by 2. So invariably now my two solution of x is going to be equal to 5 plus 1 is 6, 6 divided by 2 is 3, or x is going to be equal to 5 minus 1 is 4, 4 divided by 2 is 2. Okay, so this is how we apply the general formula, right? But that is not my my greatest emphasis, or that's not my focus. Okay, I'm going to focus on one thing in this particular formula, right? So let me write the formula back again. The general formula, that's minus b plus or minus the square root of b square, okay, minus 4ac, all divided by 2a. Now, so let's look at this formula and analyze it. Now, this formula, as we know, we have already actually used it. Okay, help us to solve the quadratic equation, to find the solution of the quadratic equation. But apart from this formula being able to help us to solve, okay, conveniently quadratic equation, there's another thing this formula will help us to do. Okay, so with this formula, without even solving the quadratic equation, okay, we can use this formula to investigate the nature of the solution. All right, we can use this formula to investigate the nature of the solution. How do we do that? So without solving, I can actually know whether this quadratic equation is going to give me real solution, okay, real roots, equal roots, complex roots, because definitely there are different, depending on the nature of the equation, you will have a different nature of solution. So what is the parameter inside this equation, right, that will make me to know, that will enable me to know the nature of my solution? Okay, that parameter is what is called the discriminant of the formula. Okay, discriminant, and we use d to represent that. So what's the discriminant? The discriminant d of this particular general formula is the expression inside the square root, and the expression inside the square root is b squared minus 4ac. So this is the discriminant. This is what determines the nature of my solution. Okay, so we are going to look at different cases. Okay, let's look at different cases of this discriminant and then the nature of the solution that I will have. All right, so I want to start with case 1. Okay, in case 1, if this discriminant b squared, of course, minus 4ac, if the value that this actually gives, the square root, what is inside the square root, is greater than 0, okay, then I will be rest assured that what I will have, okay, what I will have in the solution of that equation are real, my roots, okay, they will be real roots. Yes, so I will obtain real roots, and that's going to be 2 real roots, 2 real roots. two real and of course their distinct roots. Okay, two real root and of course they are distinct. Distinct means that they are different, they are not the same. Like what I actually got from the solution okay, of the equation that I gave previously, that is 2 and 3 is the solution. Okay, two distinct roots. So let's look at case 2. Case 2. All right, now case 2, a situation where now we are having b square minus 4ac this time around being less than 0. Okay, that is where we now have we can't have real roots, because if what I have inside here is less than 0, that means inside this square root is less than 0, that means it's gonna give me a negative sign. And I told you that anytime you have the square root of a negative real number, we treat a complex number, right? Complex number is actually gotten when you evaluate the square root of a negative real number. So once b square minus 4ac is less than 0, then definitely the roots that we'll have will be complex roots. Complex roots. Complex roots. Then case 3, which of course the last but not the least, case 3. If we are having b square minus 4ac this time around being equal to 0, okay, yes, we will definitely have real roots. Okay, we'll have real roots, but it will be equal. So we're going to have real, then equal roots. Real equal roots. So please take note of these 3 cases of the discriminant, okay, that determines the nature of our of the solution of our quadratic equation, because we are going to solve some question, okay, based on these 3 cases. Okay, so now let me clean up my screen. Let's look at a typical example. There's a question here that we need to do justice to. Example, okay. So we are asked to find the value. Find the value of a. Okay. Which the equation was the equation 3a plus 1 multiplied by s squared, all right, then plus a plus 2 in a bracket multiplied by x, then plus 1 being equal to 0. This is equation, okay. So we are asked to find the value of a that actually that makes this equation to have. Find a which the equation has equal root. So what is the value of a that will make this equation to have equal roots? It's very simple. So for us to actually solve this, remember, we have to refer to our discriminant. Okay, what is the condition of our discriminant that we actually make this equation to have equal roots? Remember the discriminant at that point. Okay, or we're gonna have b squared minus 4ac. Okay, for us to have equal real root, then b squared minus 4ac which is the discriminant, must be equal to 0. So now that's exactly what we need to evaluate now before we can actually get a value of a. So we simply means that if I should get b squared minus 4ac equated to 0, okay, of this equation, then I can simply say that this equation have equal roots. Then from there I can get my a. Okay, so now first of all, let's get our parameters. Let's start with a. What is our a of this equation? Remember, our a is the coefficient of the s square. And the coefficient of the x square from this equation is 3a plus 1, comma. What's our b? Our b is the coefficient of our x, which of course is a plus 2. Then what is our c? Our c is actually the constant value, which of course is 1. So let's apply this formula now. So I'm having b squared. So this is going to be equal to b, a plus 2 square, okay? Then minus 4 times a. Of course, my a is 3a plus 1, okay? Then times the c, which of course is times 1, is equal to 0. Okay, so you know what we do here? We have to expand this bracket. This is a perfect square, okay? I believe you know how to work on perfect square. This is going to be a square, square the very first element there, okay? Then use the 2, multiply both the first and second. 2 times a times 2, that's going to give me 4a. Then now square the last element or the last number, which is 2 squared, that's 4. Okay, so let's expand this bracket. Minus 4 multiplied by 3a, that's going to give me minus 12a. Minus 4 multiplied by 1, that's going to give me minus 4. So if I multiply everything by 1, it's still going to be the same thing, right? Then it's equal to 0. So in this case, now I think I can collect like terms. Yes, I can collect like terms. Plus 4 minus 4, they are like terms. That's 0. Plus 4 minus 4, that's 0. Then I'm having now 4a minus 12a. Okay. So 4a minus 4a minus 12a, that gives me 8a. Okay, so that's going to be a squared minus 8a is equal to 0. Okay, so guys, let's finalize this. So I have to, for me to solve this, I have to factorize. All right, a is a common factor. Then I bring the a outside, open the bracket. Then the other factor a, I put inside the bracket, and the factor for this is 8. Okay, I put inside the bracket is equal to 0. So of course now this is a quadratic expression, right? This is a quadratic equation, and I've actually factorized it into 2 products. And we know how we solve quadratic expression with 2 products, okay? When you have the product of two numbers, it's either one is equal to, if the product of 2 numbers is equal to 0, it's either one is equal to 0 or the other is equal to 0, even both of them are equal to 0, okay? So it's either I will say that a is equal to 0, or I will simply say that a minus 8 is equal to 0. So from there now, a is equal to 0, or a is going to be equal to, take 8 to the other side of the equation, a is equal to 8. So the value of a that actually we actually make this equation to have equal root is a equal to 0, a equal to 8, but I would rather, okay, use 8. So as simple as that. I hope that is well understood. Okay, so we're still gonna come back, we're still gonna solve a lot of questions based on the discriminant, but okay, we'll solve a lot of questions, but let's proceed. I will clear my screen. Okay, now remember that I'm still gonna consider my general formula, which of course is minus b plus or minus, okay, b squared minus 4ac, then divided by 2a. So as I said here, this is the general formula for solving a quadratic equation, and we already know that a quadratic equation will have 2 solutions, and that is why we have plus or minus. So if I should split now the solution of this quadratic equation into 2, okay, I will simply say that, okay, let me use s1 to represent the first one. So S1 is for the plus. Let me use that for the plus. I have minus B, then plus. All right. B square minus 4AC. This is for the first solution, then divided by 2A. Okay. Then for the second solution, let me call it S2. And I call that this time around this minus B minus into B square minus 4AC. Then divided by 2A. Okay. So these are two different roots of this equation, S1 and S2. But in textbook, okay, we commonly represent these two roots with the symbol alpha. Okay, so instead of using S1, I'll use alpha. Alpha being the root, the first root, which of course is B square minus 4AC. Okay, then divided by 2A. Then of course I'll use beta to represent the second root. That's going to be minus B minus the square root of B square minus 4AC, then divided by 2A. So what is my interest in this? Okay, my interest in this is that what if I'm being given the sum of this root or even the product? Okay, is it possible for me to actually find the sum of the root, alpha and beta, the product and the product of the root, to give me a particular value? Yes, it is possible. Let's try to get the sum. Okay, let's look at the sum of the roots. I'm only going to look at just sum of the root, which of course is alpha plus beta. Alpha plus beta, all right? So invariably now I'm looking at minus b plus the square root of b square minus 4ac divided by 2a, then plus beta, which of course is minus b, right? Minus into the square root of b square minus 4ac, then divided by 2a. Of course, you know that here I have minus. Okay, I have minus b. I have also minus. I could actually factorize this. Okay, let's do this. So alpha plus beta is going to be equal to minus b plus or minus, or plus, please pardon me, b square, okay, minus 4ac or divided by 2a, right? So of course, if I should take minus out, right, then open bracket, and this is gonna be, of course, b plus b, right? Plus b, and this is gonna be minus, because minus times minus is plus, right? Minus times this is gonna be plus, please pardon me. If I should take minus out, right, then for me to have minus b, definitely this will be b. For me to have minus the square root of b square, okay, then I have to, this will be plus, because plus into minus will still give me minus, right? This is going to be, excuse me, b square minus 4ac, okay, then of course divided by 2a. All right, so now let's just simplify this. As you can see here, I have minus, this is plus, okay, yeah, this is just from what I have here, okay, if I should actually subtract, okay, the LCM is 2a, quite well, right? Then I'm having minus b, okay, minus b, okay, then of course plus the square root of b square, for AC, then minus into the same thing happens here, okay. If minus open this bracket, this is gonna be minus. If minus open this other bracket, this is gonna be equal to b square, minus 4ac, okay. All right, so as you can see here, plus b square, the square root of plus b square minus 4ac, and the square root of b square minus 4ac. Here I have plus, this is minus. These two square roots are the same, okay, but they will cancel each other. This is plus, this is minus, they will go. So I'm only left with minus b, which gives me minus 2b. All right, then divided by 2a. All right, so now 2 cancel 2, so I'm left with just minus b all over a. So invariably now, alpha, the sum of the product alpha plus beta, okay, if I evaluate it, it will give me minus b all over a. Okay, so this is the sum of the two roots. Now, what of the product of the two roots? I don't want to, okay, prove that, but you can prove that by yourself. It is easy, just multiply alpha times beta. So when you evaluate the product of the root, you're gonna have c all over a. The sum of the root is minus b all over a. The product of the root is c all over a. Okay, so please take note of that. Take note of that. Okay, so now what is the implication of what I just did now? How is it necessary? How does it help me to solve typical questions or examination question? All right, so now we are going to look at some example so that you know the application of what I just gave you now. Example, okay, the question goes like this: if alpha and beta, okay, are the roots of the quadratic equation, and that's ax squared plus bs then plus c equal to 0. Okay, so we are being asked to evaluate in terms of a, b, and c. In terms of a, b, and c, evaluate the following: a, alpha square plus beta square, okay, then b, alpha all over beta then plus beta all over alpha, beta all over alpha, then c, the last but not the least, alpha cube plus beta cube. Okay, so solution. Now remember, we are going to solve all this, okay, alpha square plus beta square, and all we need is just what we have evaluated before, that is the sum and the product. So we simply means that, okay, for all this expression I have to actually, okay, resolve it into sum and product. Okay, that's exactly what I have to do, resolve all this expression into sum and product. So let's start with a part of the question. because I already know that alpha plus beta is minus b all over a. Alpha beta is c all over a. So how can I resolve this to either have the sum of the root or even the product of the root? Let's see how we can do that. So how do I resolve alpha square plus beta square? Okay, it's easy to resolve. It is easy. Why? Because you already know that when you have, okay, if you should expand this perfect square, you're definitely gonna have the first time and the last time to be alpha square plus beta square. You already know that already, okay? When you expand this, because I need it to be in, I want to actually resolve this so that I will have just alpha and beta. So if I do alpha and beta all square, I will definitely have alpha square plus beta square. All right. But one thing about it, it will have a middle term. What's the middle term? Okay. Just expand this. The middle term is going to be 2 times alpha beta. Okay. So we simply means that this is equivalent to this, but I must remove this middle term. So that means the only way to remove this middle term is I'll have to subtract that middle term, which is minus 2 alpha beta. So it's as easy as that. So invariably now, okay, alpha square plus beta square, okay, is equivalent to alpha plus beta all square, but I have to subtract 2 alpha beta. So as you can see now, with what I did now, I've been able to resolve this into sum and of course product. So we can solve it now. You know our value for the sum, that's gonna be minus b all over a. And of course our equation is still, please, as you are doing this, okay, always take note of your equation. And fortunately for us, our equation is still the same equation, quadratic equation, all right? So it is easy for me to just whatever I had before will still be the same with it, because it's still the same form of quadratic equation. But what if it was, suppose it was, if it was a number, right? Okay, if all these coefficients, if it were to be real numbers, then definitely what you're going to put here is going to be in terms of real numbers. Okay, so I hope you understand that. So alpha plus beta, I'm going to have minus b all over a. Remember, that's what we got, all right, for alpha plus beta. Then I have to square that. Then minus 2 times alpha beta, remember, that's c all over a. Okay, so let's actually do this. Let's work on this. Of course, if I should square this, definitely I'm going to have b square plus b square, then of course a square. Okay, then of course I'm going to have this 2c all over a. So LCM of this LCM is a square. Okay, so LCM is a square. So here a square divided by a square, have 1 multiplied by b square, I'm having b square. Then minus a square divided by a, I'm having just a. Then a multiplied by 2c, I'm going to have 2ac. So as easy as that, we have actually done justice. So this is our answer. Okay, so now let's actually proceed to the b part of the question, where we are being asked to resolve alpha all over beta plus beta all over alpha. In this case, I'll go by LCM. Remember now, okay, I have to go by LCM. The LCM of the denominator is alpha beta. So I start dividing. Alpha beta divided by beta. Beta cancels beta, I'm left with alpha. So alpha multiplied by alpha, I'm having alpha square. Then I bring down my plus, right? The same alpha beta divided by alpha cancel alpha, then I'm left with beta. Beta multiplied by beta, I'm having beta square. So it is easy now for me to solve this. Why? Because the numerator of this fraction is what we just did, alpha square plus beta square, and that is what we just did. So I'm going to just copy that. That's b square minus 2ac divided by a square. Okay, then divided by alpha beta, we know that already. That is C all over A. So of course, this is a fraction that we can evaluate. Okay, it is easy. This is something as you know how we evaluate this fraction, and that's going to be b square minus 2ac. Okay, divided by a square. So this divisor now can now change it to multiplication. Then I have to invert this division sign. Please pardon me. I have to change it to multiplication sign. Then I have to invert the divisor. Okay, the divisor is c all over a, so I will invert it. A comes up, then c comes down. So you know that a cancel itself one, cancel a square, that is a. So my final answer is going to be equal to b square minus 2ac, then of course divided by a. As simple as that. Then of course the last but not the least is difference, the sum of 2 cube. Okay, the sum of 2 cube. Now the sum of 2 cube, please take note of this. We have what is we have both difference of 2 cube and the sum of 2 cube. Okay, so anytime you are being given the sum of 2 cube, sum of 2 cube can be resolved. You can actually try that into alpha, okay, beta, their sum, then bracket open, alpha square plus beta square, then minus alpha beta. So for you to actually prove this, just use this. If we use alpha plus beta to divide this, you are going to have this other factor, right? So that's it. Okay, so what do we do? It's easy for us to resolve it now in terms of products and sum. Of course, this is sum minus b all over a, open bracket, alpha square beta square. We resolved that before. The what do we have? B square minus 2ac all over a square. That was minus, right? Minus 2ac all over a square. Then minus alpha beta. So that's c all over a. Okay, so you know what we do? So we have to now, this is going to be equal to minus b all over a, open bracket. Let's resolve the bracket. The LCM of the denominator inside the bracket of the expression inside the bracket is a square. A square divided by a square, that is 1 times b square minus 2ac. That's going to be b square minus 2ac, right? Okay. A, of course, divided by a square. A square divided by a, that's a. A multiplied by c, that's going to give me ac. Okay, so let's finalize what we are doing. This minus b all over a. So like this, minus 2ac minus ac, that's going to be minus 3ac. So this is going to be b square minus 3ac. All right, then of course divided by a square. Okay, so if you can open this bracket, minus b multiplied by b squared, that is going to be minus b cubed, minus b multiplied by 3ac, that's going to be plus 3, okay, abc. Then of course a multiplied by a squared, that's going to be a cube. Okay, all right, so that is just that. So please take note of this. I will give you the opportunity to go give you opportunity to go through what we've already treated. Then once you're done, you click on the next video. Okay, then we will continue with some other question on quadratic equation. All right, see you in the next video. Thank you very much.